today we're keeping this basic. I'm not doing the cycle, the phase shifts, because that's just like a little added confusion. We're keeping them very, very simple, just like this. We're going to change an amplitude, and hopefully we're going to change a frequency today. And we're going to do this graphing, and I'll also show you how to do it on your calculator. Okay, again, amplitude can never be negative. That's why we take the absolute value. If it's a negative in front of it, it's a reflection. Your curve goes like this. Like this. So now your amplitude is from here to here. The distance from the resting point to the top of the curve. My pen's a little off. Or to the bottom of the curve. Your amplitude will always be the same from the resting point to the top and to the bottom. That will always be the same amplitude. In other words, we're not going to change it where one dips lower than the other. They're always going to have the same up, the same down. Your period is going to tell you how long to complete one cycle. That's why we say 2 pi divided by b. Your b is your frequency, and your frequency tells you how many complete cycles do you want in 2 pi. These are all going to tie together. Good? Okay. So let's see what we're talking about here. It's still off. Okay. Now I gave you the sheet for the transformations, right? These transformations, they work the same, but they look a little different again because they're with freq. So now, and that will happen. This comes off of a basic sine curve. So right in front of this, I'm going to put your formula. So let's pull out the amplitude. What is the amplitude for this guy? 1. What is the frequency for this one? What does that mean to me? 2. Lane.
Two cycles in 360.
Good. Very good. So you know how your sine curve goes like this in 360? It's going to go like this. 1, 2. It's going to go like that. It's going to do 2 in 360. So this is 2 complete cycles in 360 degrees, or 2 pi. Okay, now we need to know how long does it take to complete one of those cycles. So this is where your period comes into effect. 2 pi over b. Let's think in degrees for a second. If I have 360 degrees in my full circle, and I need to put 2 complete cycles in there, how long should each cycle be in degrees? 180. It makes sense, right? 360 divided by 2. 180 degrees. Every 180, I should go bloop, bloop. Now, if I put 2 pi back in here, 2 pi divided by 2, isn't that also 180 pi? So my period is every pi. How many quadrants do I have to go through to get a complete cycle? 4. So here's my quadrants. Quadrants is the period divided by 4. So I'm just going to, right now I'm going to say 180 divided by 4, which is every 45 degrees. If I said pi divided by 4, isn't that the same as every 45 degrees? Every 45 degrees, I should make a quadrant. So this is how you start. You got to do this with me. Every 180, I should make a complete cycle. Start like this. In 180, I need a complete cycle. I need 4 quadrants to make a complete cycle. So technically, every 45 degrees, every pi over 4. But if I eyeball this thing, I can say this. I need to make 4 tick marks. I need 4 quadrants. So wouldn't this be halfway? They need to be equal, right? And if I took half of this, wouldn't that be my 4 quadrants that I would go through? Don't you go through 90, 180, 270, 360? Don't you go through 4 quadrants to plot those zeros and ones things that we did? So all I have to do is that. And amazingly, isn't half of 90 45? Right? So now, we're going to look at your sine curve. We're going to look at your sine curve. Stay with me. You'll get this. This is so easy. Your sine is your x or your y? Y. So remember we pulled this out. 0, 1, 0, negative 1, 0. Isn't this what it follows? So this is how we're going to do it. Just watch and then I'll do it again with you guys. We're going to start at our quadrants. These are our quadrants now. 0, 1, 0, negative 1, 0. These are the 4 quadrants we have to follow because we need 2 of these guys in 360. So again, follow that stream. 0. At the next quadrant, put a dot at the 1. Here we are at the 1. At the next quadrant, 0. Next quadrant, negative 1. Back up to the 0. Isn't this a nice little sine curve? Isn't that one complete cycle in pi, or 180 degrees? Now all we have to do is repeat this. So again, we take this guy, and we go every 45, or, because the 45 is nice, we can just split this in half. Do we have 4 quadrants to do this again? So we're going to do it again. 0, 1, 0, negative 1, 0. So I have 2 complete cycles in 2 pi. Let's go backwards. So I take this, and again I cut it in fourths. So I'm coming back here. So I have to go down backwards to the negative 1, to the 0, to the positive 1, to the 0. See the cycle? You can, without even looking at it, you can kind of see how it has to go. I have to drop down first, then up, then back down. Then do it again. Negative 1, 0, 1, 0. I'm a little bit off there. Make sense? No. Okay. We took your 4 quadrants, and we still have to go 4 quadrants. But our period this time is only pi. Yeah.
I understand the quadrants and amplitude and things like that. I don't understand
The quadrant part. When you make this, your sine curve, how do you do your regular sine curve? How do you separate this into what tick marks when you did them? When we did them Tuesday?
half pi.
Yeah, pi over 2, pi, 3 pi over 2, 2 pi. Because isn't that the quadrants of your circle, right? This quadrant. 1, 2, 3, 4.
How is that straight or not?
How is that what?
Like how is that like it's
Remember we unraveled this. Remember we unraveled it? We took our string and we started at 0 and we put these little tick marks all along. And so when we unraveled this string and we started it here at the 0 and we laid it out, this is where 90 fell, 180 fell, 270, 360. They were our tick marks. And then we went along and did the sign and we found there was a pattern. At the 0 it was 0, at the 90 it was 1, at the 180 it was 0, at the 270 it was negative 1. So we did that. At the 0, at the 1, at the 0, at the negative 1, at the 0. That was one complete cycle. But what we want to do now is make it like an accordion. We want to press this in. We want to condense this cycle to fit right here, to fit in this amount of space. We want this same thing to be inside here. So our key is, didn't we plot all the zeros and then the highest numbers and the lowest numbers? Because remember back to Tuesday when we plotted all the guys in between, we said we really didn't need those. We just need the high, the low, and the zeros. So now you want to fit 4 quadrants into this space. So without thinking angles, let's say this. We had 4 quadrants here. We need to make 4 quadrants here. This is halfway, and this is halfway. Do we have 4 quadrants there?
Just the word quadrants is dumb.
Quadrants. This is the way you plot it. That's a quadrant. How else could I say that? It's your high and your low, your peaks. So now you're starting here. You're doing this. On this guy. Here, 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 here. Okay, let me show you something else. Let's pull up your calculator a minute. Pull up your calculator. What time do we get out of here? 9:41. It's like not enough time to ever make sense out of anything. Right now I want you to put your mode in degrees. Put your mode in degrees. I want you to go to y equals, and I just want you to say sine of x. Sine of x. And before we can graph this, try. Hey, graph. Hey, graph. Doesn't look very good, right? Because we have to do this. Zoom, trig, number 7. Zoom, trig. You have to tell if this is a trig graph. Guys, I have very little time. Now, look at your quadrants again. There's your tick marks. 1, 2, 3, and 4. See your tick marks? See your quadrants? Okay, if I was to look at my table, I'd say, it doesn't look like my trig table. That doesn't look like my trig at all, does it? So I have to go to my start and tell it, start at 0 for me, and every one of those peaks and valleys that I need has to be how far apart? How far apart from this 0 to this 1? How many degrees apart? 90. I'm on a regular graph, right? So I need to tell it every 90 degrees. Don't I want to see every 90 degrees? Every 90 degrees, I'm either at a 0 or a 1, a 0 or -1, a 0. Okay, this is a regular sine curve.
Oh, okay.
Regular sine curve. If you want to graph a regular sine curve, how many degrees do you go to? You change again. 90 degrees, right? So now look at my table. 0, 1, 0, -1, 0. Hang in there with me. Hang in there. So now, watch what's going to happen. I'm going to go in there, and I'm going to say 2x. Now, how many curves do I expect to get? If I change that frequency to a 2, how many curves do I expect to get? I expect to double it. I expect to get 2 curves, and let me see if that's true. So there's 1, there's 2. Now watch. I go to my table. Good. I have all zeros. Because how is my table incremented? Every 90. But I want to tell it, where are my quadrants now? Where are my 1s and my 0s going to be located every 45? You guys were saying it was 45, right? So now I got to tell it every 45 give me a 1 or a 0. And now when I look at my table, are they there? Every 45. So yes, you don't need the quadrants to figure out how to graph this, but if you want to look at your calculator or you want to see where your tick marks are, you need to know where those quadrants are. Yes, no? Okay. The tricky part is, if I send this to a 3, okay? Alright. If I send this to a 3, I know you don't have this, so just like draw a little graph for me. Make it look like this. I just want to do this so that you get the hang of this. Okay. Right. So we're going to do this together the same way we just did. You know the 3 steps I wrote to you? That's what we're going to look at. What's your amplitude? 1. I didn't change your amplitude. What's your frequency? So frequency says I should have 3 complete curves in 2 pi. It should go 1, 2, 3. Agree? So I have, let's think degrees. I have 360 degrees to work with. I need to be every 3. So I need to go every, how many degrees? Every 120 gives me my period. 2 pi divided by b. And this says every 120 gives me my period. Degrees is a little bit easier to see. Now, I can mark this off to every 120 and figure it from there. And then within that 120, how many cycles do I need? How many points do I need to plot? 4, my 4 quadrants, right? So take 120 and divide it by 4. Where do my tick marks have to be? Every 30 degrees. So look, this is 90. How many 30s are in 90? 3. So we're going to put 2 here. Because isn't this 30, 60, 90? We're going to put 2 here. 2 here. 2 here. Now, just give me 1 second. So we're 0, 1, 0, negative 1, 0. So watch what we do. Just follow, just 1 second, guys. 0, 1, 0, negative 1, 0. Up, 90 plus 30, isn't that 120? If I change my calculator, I'd have to change my table set to be every 30 degrees, or I'm not going to see my quadrants. All right, so, God bless you. For homework, did I hand this out? Yeah. For homework, just don't do this sheet here. Just try to homework 1 if you could. See how far you get. It's asking you to identify the period.
So I did 23.
All right, email it. You're right, email you too. Email. I have both your emails, I'll email that. Does this make sense, boys?
Yeah.
You guys, you got the trick part, so I know. Does it make sense to you? A little. Reagan, you always say no, but you understand.
How much more on this?